So we are group 4 for ME 352, and our project is focused on modeling a hybrid electric vehicle. In our group, we have Alex Croson, Drake Dittman, Jake Francis, Catherine Hoppy, Armand Lannard, myself, and Corinne Sams. At our first meeting a week ago, we decided on this team structure. So I'm going to be team lead. Corinne is going to be writing lead, so anything related to writing. Jake's modeling lead, anything related to modeling, and then Catherine's going to be Simulink / programming lead, so anything related to that. The focus of our project is to create a dynamic model and control system for a hybrid electric vehicle, and there's 3 main goals underneath that. The first goal is to create a dynamic model of an engine battery series, HEV, accounting for air resistance and the incline of the road. So with this model, we're not trying to attempt to model the turning, mostly straight backward and forward on a slope with air resistance. The second goal is to create a dynamic model of the state of charge of the battery during operation, which is essentially just tracking what does the battery look like as the car is being used. And then the third objective is to, at the end of all that, design a controller for the overall system. This project there's a lot of important features of this project, a lot of important implications for society. These are just a few of them. So HEVs, one of the reasons they're kind of sought after is because they increase your fuel efficiency and reduce your overall fuel cost. They provide you the ability to have instant torque, which can be important in certain towing applications or on steep hills. Some European countries require that cars do not idle. That's why you see the cars that kind of kill the engine when you're sitting there for more than a second. HEVs provide a way around that by having a battery fill in the gap. And then the environmental impact, obviously by having a more fuel efficient car, you're able to reduce carbon emissions and have cleaner air. The flip side is there's also a negative impact because a lot of the source materials for batteries, the mining of that can be highly toxic. And then the electric grid, there's also an interesting implication where if all cars switch to fully electric, the impact on the electric grid is predicted to be highly negative unless that's spread out over a very long period of time. Whereas HEVs kind of provide a middle ground where you don't overwhelm the electric grid, but you still have the benefits of increased fuel efficiency. So we read through a lot of papers over the last week, and the model, the HEV we kind of settled on to model was this hybrid electric vehicle race car, which you can see on the right. These are the system specs that we're going to be basing our model off of. And from that paper, where we got those specs, we also got this nice functional block diagram. So this shows you what a series battery HEV looks like. You have a fuel tank, which feeds into the internal combustion engine, which feeds into a generator, which goes to a power converter. That power converter can either charge the battery or have the battery feed into it. And those two things together then goes into the motor, which then goes into your drivetrain and moves the car. So this is for objective 1. And then our second objective is to model the battery. There's 2 main approaches we've seen and that we're currently still exploring the full details on to nail down which one we're gonna go with, which approach we're gonna go with. But the first approach is to essentially take an electric analog model with single battery, which is usually a series RC circuit, and then scale that through a series and parallel connections to represent a full battery pack, which goes into a car. And then the second approach is to model the battery pack itself as a single battery system using parameters that don't depend on each individual battery cell inside of it. Both approaches have their advantages and disadvantages. Approach 1 is easier to get a good model. Approach 2, you either can get a great model or a crappy model. Not really much in between. So that's we're still working through which one of those we're going to go with. So our next steps over the next 2 weeks are to really nail down our research on the ethical and professional implications of this project, to create a literature review, and a repository of our citations to begin modeling the HEV in the battery system, and hopefully over the next 2 weeks to finish that modeling so that we can begin the Simulink modeling towards the end of that. That way we have time this semester to get to do the time response analysis. Thank you.